In this video, we're going to look at part B of example 1 on page 68. In part A, we saw that x equals 4 cosine t, y equals minus 4 sine t gave us a circle of radius 4. In part B, we are looking at something that is similar. Again, we have x is equal to 2 cosine t, and z is equal to 2 sine t, and y is constant equal to 1. So this curve lives in 3 space. Before the two examples that we saw, they were just living in the xy plane. But now we actually have something that lives in 3 space. Fortunately, y is constant equal to 1, so we're going to ignore that for the time being, and we're going to start by plotting what this curve looks like in a projection onto the xz plane. We are just going to plot a projection in the xz plane. And so if we just concentrate on x equals 2 cosine t, z equals 2 sine t, we could go through again and make a table of values. And I'm just going to skip that step and instead see if we can draw right away. So we have x, the x-axis right here, we have the z-axis right here, and then we have x equals 2 cosine t, z equals 2 sine t. So for t equals 0, where are we? When t is equal to 0, we are going to look at the point 2 cosine 0, that's 2, comma, 2 sine 0, that is 0. So we are starting at the point 2 comma 0. Let's draw that over here. So that is the point at t equals 0. At t equals pi over 2, we are going to have 2 cosine pi over 2, that is 0, and 2 sine pi over 2, that is 2. So we're getting the point up here on the z-axis. And if we do this for pi, you will find that you get the point minus 2, 0. And when you plug in 2 pi, when you plug in 2 pi over 3, when you plug in 3 pi over 2, when you plug in 3 pi over 2, then you are down here on the z-axis at minus 2. And so it looks like, again, we have a circle, this time of radius 2, centered at the origin. So this is what this parametric curve would look like projected onto the xz plane. Now, really it lives in 3 space. So now we're going to take this one step further and draw it in 3 space. So here I have my x-axis, my y-axis, my z-axis. And now we are also going to pay attention to y is equal to 1, no matter what time we are looking at the particle moving along this curve. The y value is always 1. So let's say 1 is right here, y equals 1. And the x and the y are still determined by our previous curve right here. This just doesn't really live, the circle doesn't live in the xz plane, it lives in a plane that's parallel to the xz plane for the value y equals 1. So we are getting a circle centered on the y-axis at y value 1 and moving around, and the radius is 2. So my picture isn't the greatest, but so this is 2. right here. So the radius is 2. So we have a circle of radius 2 that is centered not at the origin, but x is 0, y is 1, and z is 0. So it is centered at the point 0, 1, 0. Now the last question is this circle oriented clockwise or counterclockwise? Going back to our projection in the xz plane, we started over here on the positive x-axis and moved left. So we went counterclockwise right there. If we keep that orientation, then we are going to get an orientation that moves around this way. So we are moving around this way. We started at the positive x-axis and moved towards the z-axis. And so if you are imagining that you are standing on the positive y-axis and looking in this direction towards the circle, then it is oriented clockwise. So this is oriented clockwise when viewed from the positive y-axis.